cohort 5, and as part of that we have this buildathon. And for buildathon we have quite like two categories in which we had to make the products. Actually it was difficult to decide on which product we should make a backend and UI, so basically and hold application. So I have chose the first stream under which I have chose a workflow orchestration platform. So today I'll be going to demo you the project which I have built in 2 weeks using AI tools as well as my core backend knowledge, and of course as well as with the knowledge which I've gained from coding shuttle. So my project is like FlowForge. So FlowForge is an event-driven workflow orchestration platform designed to build, version, execute, and monitor workflows as directed acyclic graphs. So the idea is simple. Like instead of hard coding business workflows into application code, like FlowForge allows team to visually compose workflows, configure individual nodes, connect with them like edges using conditional edges, version those workflows, and execute them asynchronously. So under the hood, isn't just a visual builder. So we built this using the whole backend with Spring Boot, Redis, Kafka, and very much like production grade backend. And we have kept a lot of system design concepts as well, like idempotency, retries, transitional outbox, dead lettering, and like caching, rate limiting, and much more stuffs like distributed transactions, all those things like that. So let me show you how it looks like. So basically we have created two things. First is backend, which is of course in Spring Boot, and we have also made a nice front end using Laravel. So this is how the front end looks like, but first I'll like you to walk through all the APIs which we have built. So this is our collection. I'll quickly walk through the features which we have built and the APIs which we have. So like initially we have these auth APIs, and we have used like Spring Security, and we have used JWT authentication for our application. So we have register, login, and refresh token APIs for that. Second thing is workspace. So like we have created this as this kind of so we already have n10 kind of applications. So we have created a similar workflow orchestration platform. So what we will do is we will first have workspace. So we will create a workspace, then we can get that workspace, like we can get the list of that, or we can get it by ID, and under that workspace we can create multiple workflows. So we have APIs for workspace, we have APIs for workflows. So under workflows, this is a huge chunk. Actually this is the like core logic of our applications, and we have a lot of APIs there in workflows folder. So first one being create workflows, and later on we have to get that workflow by ID and all. So we have also implemented versioning. So what we can do is like we can create a version, either we can clone a version with, which we already created, where we already have a graph. So that will clone that graph, and we can tweak that graph. We can then add that, like put that graph, we can get that graph. So and we also had a functionality called publishing the version. So let's say we are making a lot of versions, so we can publish either of the version and execute that. So next thing is like execute workflow, which is the main functionality basically, and then we can get the execution results, and we can get execution results per node as well. So these are some of the APIs. We can quickly go through our UI. So this is the first screen where we can sign in. So I'll first sign in with our test user. So this is the test user, test@example.com. Password is this, and we'll sign in. Okay, so now we have signed in. It should navigate us to the dashboard. Alright, we can ignore this. Alright, so currently we have a limited front end. So we have already created a set of workspaces. So we have these 3 workspaces, out of which we will select the third one. So on the third one we already have a set of workflows already created. So we can open an existing one just to see how it looks like. So this is our canvas. So here we have 3 nodes. So So each node is an executable node. So currently this one is trigger. So once it's triggered, we have a HTTP node. So here what it will do is we can just click on it and we can check the configuration. I can just pull this here so it doesn't block the screen. Okay. So we have this HTTP node under which we will call a get API. So this is just a static URL. So it will give us a response. So here also what we will do is before executing we will pass on an user ID. So that user ID will be directly propagated to this input.user_id placeholder. So we can handle both type of requests. Either we can give directly the value or either we can give parameters. So these parameters basically helps us propagating inputs and outputs to different nodes. Let's say we are inputting an parameter in the first node, so that will be propagated to the next node as well as an output if you want, and that second node might use output of the first node in the request. So we have created a system to propagate the status, propagate the parameters from single node to different nodes. And this is how the edges looks like. So this is a normal edge where the source trigger ID and the destination IDs will be stored. We can also have conditional edges. So this is an example of conditional edge. So this one, what it does is so based on the response, what we can do is we can put a condition in the edge that if this condition is met, then only we will go through the next node, otherwise it will be skipped. So this way the conditional edges will work. We will definitely show how these kind of workflows are created. So basically these kind of workflow is normally called directed acyclic graph in our technical terms. So we have few more things in our plate which will be demoed in few seconds. So this is how it looks like. We have functionality to clone the current version. We have functionality to add a new version. Also we can see the history. So if we can see history, like it will be the past histories, and we will be getting the generic success scenario. So in this case the condition was failed, that's why it skipped the last node. So we can definitely see the whole execution result as well as the execution result per each node as well. So here we can see like this was the input of the node and what was the output. So there was no output for this particular node. So the whole execution history will be shown here as input, output, as well as status, and when it was started, how much time did it take. So it took around 200 milliseconds, 46 milliseconds, like that. Now we can just go ahead and create a new workflow. So this is how we will create it. So currently let's name it as demo 2. Okay, and we can give it a description like demo 1 workflow, that we will be able to create. Since it doesn't have any version, we will have to create the first version. Now it will show us that it's the version 1. We can either clone, create new versions, which we'll see later. So let's create this first trigger node. So this is a trigger node. We don't want any configuration here. It will just trigger our execution workflow. So it's just initial point. Then we will have a HTTP request node. So the HTTP request node, we can do the same thing. Probably we will have the same API. This is just to demo how it works. Okay, so it will take input.user_id, and we don't want to give any query pair inside our body. So this way it will generate a raw configuration which we will pass in our request body. This looks good. We can give it a name like get posts. This will be nice. Okay. So then we will have, so we have more functionalities as part of nodes. So we also have an AI prompt node. In AI prompt node, what we can do is we can give an AI prompt like summarize the user data, or we can give any other use case as well. Currently we don't have API key integrated, so we can't test it, but I have created a nice documentation where in just one place we will just have to provide an API, open API, like OpenAI's API key, and this will be really work, like it will be good to go. So I've tested it in our like local model, it was working fine. So in order to like evaluate it, we can just add that API key in our backend. Okay, so currently we don't want it, I'll just delete it. Then we have a conditional node, we have a transformation node, we have a delay nodes. So these are like future enhancements, and we are also planning to future like enhance it with the connectors. So there we can connect with GitHub connectors, we can add LinkedIn connectors to perform more user operations. But yeah, for now we can just move ahead with this. We can so currently, since we have two nodes, we also have created DAG validator. So that way what it will do is it will validate each and every directed acyclic graph. Since we can't allow cycles, we can't allow orphan nodes, so that way it should not allow us to create. So if we try to save, it should not save. So now it is saying that workflow contains unreachable nodes. That means we didn't give an edge. So what we can do is we can just create an edge like this, and what we can do is we can put it a conditional edge basically. So what condition we can give, we can give it something like user dot id equal to 1. So what we can do is if the user dot id, I can say specifically input dot user dot id. Okay, we can yeah, we can save it. So now it shows us like this, that input dot user id equal to 1. If this condition satisfies, then only it will execute this node, otherwise it will not execute this particular node. So we can just go ahead and try to publish this version. So let's click here. So this way it will publish the current version. So current v1 version is published. This is a common status here. Like let's say if we create a new version, then it will not show as draft, since we like there are like two versions in this particular workflow, and one of the version is already published, so this status will not change to draft again now. So what we can do is we can try executing this one. So what we can do here, we will give as okay, so here what we have is we have user id, so we should I think change this. So I think we can validate one more thing here. Yep, so this is the validation. So published version workflows, published workflow versions cannot be modified. So this is a feature. If we have published our version, we cannot modify that version, but we can definitely create a new one and modify it. So we will clone it, and we have a new version. So now the current version is v2. We can click here in the condition. We can just remove this, and we can save. Great. Now we have version 2, and I want to execute version 2. So let's go ahead. We give input JSON as user id 1. Let's run the workflow. So what it will do is it will push this to a topic, and the status will remain as queued. What in the background it does is we have workers. So workers will pick whichever the execution is there in queued status. It will mark them as running. It will run the each of the nodes. It will go through each of the nodes. Then after successful completion, it will mark it as success. If in case either of the node is failed, it will mark the execution as failed. So currently our execution is successful. We can go ahead and check the history. So R1 was demo-2. So let's check the history of this. And the recent execution is this one. We will click on it. and what it will do is okay, so here input dot user id. Okay, so the earlier JSON was correct. So that way we have validated that if the input path is not correct, if the condition is not met, the next node should be skipped, and this is exactly showing that behavior. So we can see that this particular node is skipped, and it was succeeded since the first node was succeeded, and next there was no node to validate. Now let's try and validate the first scenario. Since we already have the v1, we can execute that. Let's get this one here. I think the input dot user id dot user dot id should be correct, and let's go ahead and execute this. Okay, so again it will be in queue status. A worker will pick this up, and that will be executed. So let's see. Now it shows succeeded. Let's check the history. So this is the latest one. Open it. Strange. Here we have input dot user dot id. Okay, something is not correct here. Anyways, let me show you the correct one. So we already have this GitHub PR review. This is just a name. Don't get misled with it. We'll just open it. Here we have that particular conditional node. So this one is nodes.getUser.name is equal to meet. So let's go to version 8, and this should be nice. Okay, so what here we will do is since we already have this input.user.id, okay, so we have done actually input.user.id. It should be this input.user.id. That's fine. So it will get one particular user, and from that output we will propagate that output in the input of create post. So between that itself, it will check that if the get user.id is equal to 1, then only it will create post, otherwise it will not. In our case, it should create the post since we will have user id as 1. So let's quickly execute this one. I will start running execution. Here we should be able to give get all 3 nodes executed. Let's see. So now it's now a worker has picked that up. It marked initially it as running, and then after executing all nodes, it marked as success. Great. Now let's open the history. So this is the latest run. See, now you can easily walk through each of the nodes. So the input was user id 1, and here it was here. So output was id as 1, and this is input of so this particular node is named as get underscore user, right? So get underscore user has this id variable which we have passed here. Okay, see, we have input as the response of previous output. So this way we will validate the condition that get underscore user dot id is equal to 1. Since that was equal to 1, create post http node also executed. So this way, and the output of that was id is equal to 101. So that way this conditional edges works, and the whole DAG executes. So if we will validate earlier run, there we had a condition. So what was the condition? It was user.name is equal to meet, but currently user.name is equal to Lenny, right? So in that case the condition failed, and it didn't go to the next node, and that was skipped, but it was marked as succeeded. So now I think we can also check one of the execution where it should be failed. So let's create a new version, and we can check a failure state. Okay, so let's clone this and we can edit this get underscore user dot id equal to 1. We can keep it as this the earlier one, but now what we can do is so first let's say this, open this, create post, and let's try manipulating our URL. So let's say I've added a character J so that it creates invalid URL, and let's save it and try to run it. In this case, it should fail at the last node. So since the workflow graph is saved, let's execute it. We'll keep it same. We can keep it empty as well if we don't want any input JSON. But in our case, since we are propagating this user ID to the first get post API, we'll keep this JSON as it is. So let's run this execution. Again, the execution will be similar. It will go into queued, and see, we have failed status. Now let's go ahead and check the history. So the history is the first two node got successful and the condition was true. It propagated to the third node, but since our URL was incorrect, we got an error. So this is how the execution works. So we have validation of DAG at two places. Once we create an workflow, at that particular time we can put the graph. We validate if it is a valid DAG or not, if it contains cycles or not. We cannot create any acyclic graph, and we cannot create any graph which doesn't have a node with edge. So these kind of validations are already performed while creating graph as well as while executing the graph. We have also used idempotency, but in UI we didn't use it. In our Postman we have that, which I'll show in some time. Since due to lack of time, I couldn't integrate it in UI. So this particularly showcase each and every features of our workflow orchestrator. I'll just quickly see if anything is pending. I think no, yeah, we are good with this. Now I would like to walk through few of the APIs which we haven't covered as part of UI. So we haven't covered workspace related APIs, so we can create a workspace like this. Firstly, I would like to log in and then showcase each of the functionality. So let's go ahead with login. So just click login. It will give us access token. Let's create a new workspace. So we already have FlowForge demo 3. We will create a new workspace named demo 4. Yep, now we have created the demo 4 and we can validate it here as well. So we should now get workflow demo 4 as well. See, we have it. Currently we don't have any workflow. Let's create it from here. And similarly we can get a number of workflows per workspace as well. So I think we have 4 workflows as part of this workspace, which I am an owner of. So we have these 4. We can get it by the ID as well. So now let's create a workflow. I'll just give it as testing from Postman. You can give the same description as of now. Alright. We can get workflows as part of our workspace that we have already seen. So just do it again. So currently for this particular workflows, we just have one version, so it should just show the whole picture of just one workflow. Let's move ahead and see. So this will get that workflow by ID. So in case we want to clone the version, or if we, so currently we don't have any version, so let's create the first one. So we'll hit this API and it will create version number 1. Then what we will do is we will add a graph. So here this way we will have a graph, so where we will define nodes, And in nodes we will define configuration. Wherever the HTTP request is there, we can specify the method and URL, and wherever it's not an HTTP, we can just skip it like this. We can keep it empty. We will have to define the edges, where we will define source and target. Wherever we want a condition, we will define condition like this. So let's put this graph, since it's version 1, we will put version 1 here. Let's send it. We have a nice graph set, so let's try getting that graph as well. So this is version 1, let's try to fetch it. So for the version 1, we have this graph, and since we already have the execute workflow API, we will try executing of this graph. So let me have this workflow version ID, so we can do it with this. So we have two ways to execute. Either we can just provide workflow version ID here, or we can what we can do is we can publish this version. So let's since we already have used workflow version ID in our UI, let's validate the other one. So I'm publishing version 1 as of now, and we have this API where we don't want to provide workflow version ID. We can just execute the latest published version. Let's try doing that, and we have gotten response like status is queued. So if we will get this execution, I think we should get it, and we got a success. I would just like to check with this execution ID, since this was an earlier one. So let's replace it with this. Okay, now we should get the exact status. Yeah, now we are getting status as failed. Let's quickly check where it is failing. Replace it with same. We have it. Send the request. Okay, on the second version it is failed. So let's check. I think we might have given a URL which was incorrect. If we will check that, input.user ID. Oh, so you can see we haven't provided an input user ID here in the body. That's where it didn't recognize and it failed. Whereas in our execute graph, we have this input user ID. Let's just quickly wrap it here as well. Let's paste it. Send the request. Now it should go ahead and execute all nodes. So let's replace this. Let's send the data. Okay, get user. So we have completed all the node executions, and now it should give us success status. Let's try. Yep, we have a success now. So this is the whole picture of our workflow orchestrator. In the backend, we have used a lot more concepts of idempotency. We have used outbox patterns to publish our to handle basically other event-driven architecture, where we have used Kafka as well, and we have used other concepts, production grade concepts. So we have also used Flyway for our migrations. So I'll quickly walk through. I'll just take few minutes to show you the README file of our code, and basically our architecture as well. So we can see it in our other branch. So this is the README. Currently we have created a really nice documentation which will showcase each of the things. This is a nice diagram created, but we also have a image of a diagram, and I'm more leaning toward that because it contains all things here. So here we have a nice UI created by LLM, and some manual integrations as well, since we have used Lovable and it has limited credits. So we got an initial boilerplate code and we have integrated, I've integrated it with our backend as per our APIs. I just like to show this diagram. So we have used React in our front end. We have used React Flow to build this DAG, and we also have given functionality to create workflows. We have functionality to build our DAG using different nodes and connectors. Connectors as in edges as of now. We don't have external connectors. We can also do versioning and cloning. We can execute. We can do monitoring of the executions, and there will be an added feature called AI Workflow Designer. I was targeting to do that, but I couldn't create a nice UI for that. But we already have that functionality. We already have an API for that. I'll just mention the steps in our documentation to test that. So what we can do is we can give a nice prompt and it will create the whole DAG itself. And the other thing is we also have an AI node which we can use to summarize. We can use to do other stuff, as I told earlier. So our React will call our backend. So in backend we have created a modular monolith architecture instead of creating microservices architecture for this one. So we have different modules. We have workflow modules. We have execution modules. Then we have other modules called like workspaces. We have also versions, and we also have used Spring AI for doing the AI related stuffs. And if I'll talk about the features, I already talked a lot about it. Like we have transactional outbox patterns, we have idempotency, we have retry and backoff. We have also used DLT. After 3 retries, it should go to DLT. So currently we are not doing anything with the DLT. We are just logging whatever failure is there in our dead letter, after consuming the dead letter queue. Then second thing is distributed locking. We also use rate limiting. So currently we have just used fixed window rate limiting as of now. We did Redis caching as well. We have also used Redis for locking the workflow execution. So let's say we are executing one workflow, and if we again want to execute that, if any other thread want to execute same, it will not do it until and unless the whole thread is processed, the whole workflow is executed. We also used Redis for caching. We do get the graph a lot, so at that particular point we have put Redis caching, since one published version will never it will never change. So that published version we are storing it in our Redis cache layer itself, so that it just fetches from that instead of going to database every time to get the same published version of that workflow. And we have used PostgreSQL as our database. We have so after we have used Redis, Apache Kafka, as I've already said. We have workflow workers which will pick up all the entries which are in queued status from database, and it will execute each workflow asynchronously. And we will keep polling the status from database from our UI to get to monitor the workflow. And we have used Spring AI, as I've already said. This is a nice short architecture diagram which we have made. Yeah, so this is all for our FlowForge, and yeah, I look forward to enhance it more. I have few more ideas to enhance it, but for now, for this hackathon, this is much I could do single-handedly. So yeah, that's all. Thank you.